This is Mrs. Cahill with Lesson 5.1. We're taking notes on angle pairs. First comes adjacent angles. Adjacent angles share a side. So in the diagram below, I can see that I've got two angles that share the side BC. So I know that angles 1 and angle 2 are adjacent. And adjacent just means next to. Complementary angles. Complementary angles add up to 90 degrees. And I see here I've got angle A and angle B. 35 degrees plus 55 degrees adds up to 90. So I know that we've got complementary angles. And in the white space to the right, I'd like you to add this diagram. I'm going to take two lines, or in this case line segments, and I'm going to draw them so that they appear to be perpendicular. And I'm going to indicate to you that they're perpendicular by putting in this little red box. And that tells everybody we've got 90 degrees. And right now, I only have one angle. But if I put in a side in the middle here, a ray here, I create an adjacent side in the middle. I've got two adjacent angles, angle 1 and angle 2, and they form a right angle. Well, if I were to tell you that angle 1 was 30 degrees, you would know that angle 2 was 60 degrees because we know they add up to 90 because of the red box in the middle here. So I know the measures of both angles have to add up to 90. 30 plus 60 equals 90. So my complementary angles could be drawn separately as in the first pair of angles or adjacent. In either case, they add up to 90, so they are complementary. Supplementary angles add up to 180 degrees. Angles A and B are supplementary because 110 plus 70 is 180. So I can see angles A and B are supplementary because they added up to 180. Linear pair. So a linear pair, see the word line in there? A linear pair forms a line and they are adjacent to each other. And they are also supplementary angles. You might remember in the past that a line has 180 degrees in it. Well, if I add an adjacent side, and I've got two angles now, I know that together they need to add up to 180. So x plus 130 adds up to 180. Then I can do the math in my head. X needs to be 50 degrees because 50 plus 130 equals 180. Vertical angles are opposite each other when two lines intersect. So I've got two lines here, first line and my second line, and they intersect at this point, and when they do, I create four angles. Well, angles 3 and 4 are opposite each other. Also, angles 1 and 2 are opposite each other. So that's my two sets of vertical angles. Well, here's the important part. Vertical angles are congruent, and that just means that they're equal in measure. And here's what I mean. If I were to tell you that angle 3 were 140 degrees, then you know that angle 4 is 140 degrees. If I were to tell you that angle 2 is 40 degrees, you would know that angle 1 would also be 40 degrees. Vertical angles are congruent. All right, I want you to pause the video and do these practice problems. Use your notes to help you. Then you can restart the video and compare your answers with mine. Okay, Let's find a pair of adjacent angles. Remember from the definition, adjacent angles share a side. Now there is more than one pair. I'm going to show one pair. I see that angles 3 and 4 are sharing this side. So angle 3 and angle 4 are adjacent. You could have chosen others. Now for complementary angles, you should look up that definition. That means they add up to 90 degrees. And we know that right angles have 90 degrees. And they've given us this mark right here. I know that angle 3 is 90 degrees, but by itself, angle 3 can't be complementary to itself. However, here's the neat part. If I've got a right angle here at 3, then I've got another right angle right here. So that means that angles 1 and 2 form a right angle, so they are complementary. Angles 1 and 2 are complementary. Number 3, supplementary. Supplementary means they add up to 180 degrees. I know that there's 180 degrees in a line, so I've taken one of my lines and I've traced it. And I see over here I've got 1, 2, 3 angles that make up that line. But supplementary means I need to just have 2. So let's not use those 3. Let's use these 2 over here. So I can see that angle 5 and angle 4 are supplementary. Finally, vertical angles. Vertical angles are formed when 2 lines cross. So I've got a few lines here, and let's take 2 that cross. I've already traced one in red, and I've traced another in red, and I've got 2 lines that cross. So 2 angles that are opposite each other when these 2 lines cross would be angles 1 and angle 4. All right, now let's turn the page over and talk about parallel lines. Parallel lines never intersect. And we've got some parallel lines here. I can see that line A and line B are parallel. They appear that they're never going to intersect. And actually, I tell you that's my intention by putting these little arrows here. This is how I tell you that line A is parallel to line B. A transversal intersects 2 or more lines. It's a line that intersects, not parallel, intersects 2 or more lines. So for instance, in this diagram here, I could take this line T and show you it's my transversal because it's intersecting. Line T is intersecting lines A and lines B. Line A and B are my parallel lines, and line T is my transversal. Now let's talk about the angles that are created. When I've got my 2 parallel lines and my transversal, I have created 2 intersections, an upper one and a lower one in this case, and I've created 1, 2, 3, 4, 5, 6, 7, 8 angles. Well, some of these angles are on the inside. They're my interior angles. Let's go see which ones. If I consider my parallel lines to be my walls, on the interior would be all the angles there highlighted in red. I consider them to be protected from the wind. They're on the inside of the house, keeping warm. And those in this case would be angles 3 and 4 and 5 and 6. They're on the interior. Now let's talk about the exterior angles. Those would be the other 4 that are on the outside of the house, where they're not protected and the wind can get to them and it's cold. That's why I've made it blue. So they're on the outside of the picture, and those would be angles 1 and 2 in this case, and 7 and 8. All of those angles are on the outside. You do not need to label your picture with this shading and with these words interior and exterior. It could make your drawing a little complicated. However, if you find it helpful, go ahead and do so. So now use that diagram, and the reason I didn't want you to add that to that diagram, I need to use it now to talk about my different types of angles. First, let's talk about alternate interior angles. Well, interior, we already know that means they are on the inside, but the alternate part, that means they are opposite of each other. They're on opposite sides of the transversal. So here's what we're talking about. They're on the inside. That's what interior means. Let's go over here to this diagram. Do you see those two angles that are highlighted? They're clearly on the interior of my two parallel lines, and they are on opposite sides of the transversal. One is on the right, and one is on the left. Well, when my two lines are parallel, my alternate interior angles will be congruent. And that just means that their measures are equal, and that's important to know. So let's go up to the diagram at the top of the page. See angle 4? Who is he alternate interior to? Well, keep in mind the interior angles happen on the inside, so I see 3 other angles on the inside. I want somebody that's on the opposite side of the transversal. That would be angle 6. So angles 4 and 6 are alternate interior. Now, let's find out who's alternate interior to angle 3. So here's angle 3, and I want the guy that's on the opposite side of the transversal, but still interior, and that would be angle 5. And remember, they're congruent to each other. Now let's talk about alternate exterior. Well, like the name says, exterior, you know what that means. They're outside. And they are on, again, opposite sides of the transversal. Alternate means opposite. So we would call opposite and alternate, to be synonyms. So if they're on the outside, I could highlight them. See over here, I'll highlight my outside angles. And they're on opposite sides of the transversal. Going back up to the diagram, I want to find who is alternate exterior to angle 1. Okay, so let's show who's on the outside. I've highlighted the ones that are on the outside. We're talking about angle 1, and I want to know who's on the opposite side of the transversal on the other intersection, and that would be angle 7. Now let's find out who's alternate exterior to angle 2. On the outside, I've got my choices, but the only one that's on the opposite side is angle 8. So those are my alternate exterior angles. And the important thing to know about those, alternate exterior angles are congruent. That means that their measures are equal on the two lines in relation to the transversal. That sounds kind of confusing. Let's look at this diagram real quick. We've got our transversal, and we have our little parallel lines. Well, when we have our picture here, we've got 2 intersections, an intersection here and an intersection here. Corresponding angles are in the same location at the 2 different intersections. For instance, this angle right here is in the upper left-hand side of this intersection. And this angle here is in the upper left-hand corner of the other intersection. They are in corresponding locations. Corresponding angles are also congruent, which again means that their measures are equal. So let's talk about who's corresponding to angle 1. So I've got angle 1 here. And I have my two intersections. We'll call one the blue intersection and the other the green intersection. So imagine that we've got streets A and B and they're being intersected by street T. If I live in house 1, right here in house 1, in the blue intersection, who lives in the corresponding house to my house? Well, my house is in the upper left-hand corner, and house 5 is in the upper left-hand corner. They are in corresponding locations. Now let's see who's corresponding to angle 2. So angle 2 is in the upper right-hand corner of the blue intersection. Angle 6 is in the same location on the green intersection. So 2 and 6 are corresponding. Now let's talk about angle 3. Who's in the same location as angle 3? Well, angle 3 is in the lower right, as is angle 7. They are both in the lower right, so they correspond to each other. Finally, angle 4 is in a corresponding location to angle 8. They are both in the lower left corner of their intersections. So now I want you to practice, but before you do, what I've done is taken my parallel lines and I've drawn them a little differently than the last time. So you don't need to copy this down, but I want you to see it. I have highlighted my interior angles in red, and I'm highlighting my exterior angles in blue. And that might help you to see who's on the exterior and who's on the interior. Remember, I think of my parallel lines as the walls of a house, and anybody between them is on the inside and protected from the weather, and they're nice and toasty warm. Okay, now you can compare your answers to mine. Alternate interior to angle 2 would be angle 8. They're on the inside and they're on opposite sides of the transversal. Corresponding to angle 3 in the same location would be angle 7. Of course, I just skipped one. I want alternate exterior to angle 7. So I'll circle angle 7 in blue. Who's on the opposite side of my transversal and also exterior? That would be angle 1. Okay, now I want a vertical angle to angle 6. So angle 6 is right here, and vertical to it would be angle 8. So I've got these two lines, and they create angles that are opposite each other. So vertical to angle 6 is angle 8. Now I want adjacent to angle 1. There's more than one angle adjacent to angle 1. If I'm talking about this line, I could say that angles 1 and angle 2 are adjacent. That's the answer I chose. However, if I were talking about this line, I could say angles 1 and angle 4 are adjacent. Either answer is good. Linear pair with angle 4 could be angle 1. Okay, now let's go to the second part. If the measure of angle 1 is 110 degrees, then let's find the other measures. So I'm going to put in my 110 degrees here, and I'm going to find the measure of angle 7. Plus, I must explain my reasoning, how we know. Our reasons come from our notes that we've already taken. So what's the measure of angle 7? Well, I know that angle 7 is going to be 110 degrees. But how do I know that? Well, what's the relationship between angles 1 and angle 7? They are alternate exterior angles. I abbreviated that. So now let's talk about angle 5. If angle 1 is 110 degrees, then I know that angle 5 is also 110 degrees. That's because 1 and 5 are corresponding angles. I abbreviated that and just called it corresp, but it's corresponding angles. Okay, so now when they change the directions, we get to erase the 110 degrees. We'll put in the 60 degrees for angle 8. 60 degrees. If angle 8 is 60 degrees, then what is the measure of angle 2? So here's 2, here's 8. Those are alternate interior angles. Therefore, I know that they are congruent. So angle 2 is 60 degrees. Now what's the measure of angle 3? Well, 8 and 3 aren't anything special to each other that I've taught you. However, 2 and 3, remember we said that angle 2 was 60 degrees. Well, 2 and 3 form a linear pair. So I know that to get angle 3, I will take 180, I'll subtract from it 60, and I get 120 degrees. 60 plus 120 add up to 180. And I know this to be true because these two angles are a linear pair. So you've taken your notes on 5.1 and you are set to do page 3 in the packet. Please check your answers with my key. And then page 4 in the packet. Again, check your answers with my key. All of that becomes homework if you don't finish it in class.